Question number 6. Anyone? An electron is released and the charge is right now for the plate is positive. Obviously, it will try to get attracted towards this one beta. So with what force it will be attracted? In electrostatics, we know the force will be equal to how much? Charge into electric field. So if I equate with this one, what is an acceleration of this one beta? Acceleration of the charge particle will be electric field into charge divided by mass m. What is telling is right now in the problem, electron is released from the rest distance d from a long uniform charge plate with a charge density plus sigma. When electron just reaches the positive plate, its speed is right now for me v. If distance between the plates and the electrons is reduced to half, then the electron is released. Okay. The new speed of the electron when it reaches the positive plate will be equal to your how much? Okay. First, let us try to calculate the speed formula better. V square minus u square is equals to 2s. Initially, the body is at your rest. Okay, so V will be equal to how much? Under root of your 2a into s. S is nothing but given in terms of your d. So this is the formula, velocity. In terms of your acceleration, I can write as of your charges right now for me the same. Okay, now if the distance is reduced, then what is happening, beta? If distance is reduced to half, then velocity of electron in reaching the plate will become how much for me? Change. So I can write this one as V1 is equals to under root of your 2 into your AD divided by root 2 beta. Because d value will be equal to d by root 2. Okay. So this value will become how much for me? V divided by root 2. So with respect to the initial velocity, it will become half of your distance. Clear? So the answer must be equal to how much for me? V divided by root 2. Clear?
Yes, sir.
Sure. The next one is kinematics question. The next one is eighth one is zero. The moving coil galvanometer, the deflection in the coil is 0.02 radians. When a current of 20 milliampere is passed through it, if the torsional constant of the suspension of the wire is 2 into 10 power minus 3 Newton per meter radian, magnetic field is 1 into 10 power minus 3 Tesla, the number of turns in the coil is 200, then area of the each turn of the coil will be equal to how much? Torque acting on the coil is tau is equals to your ban into your I. Okay, tau will be equal to how much? Constant. C into theta is equals to ban into your I. Okay, so torsional constant is right now for me theta divided by your I is equals to your ban divided by your C. C is nothing but equal to your torsional constant. Clear? So deflection in the coil is given how much for me, Orbiter? Theta value is given. He's asking us to calculate area. So A value will be equal to your theta into your C divided by B and into your I. Okay. So torsional constant and theta value is 0.025 multiplied by C. Torsional constant is 2 into 10 power of minus 3 divided by B. Magnetic field is how much for me? 10 power minus 3 into number of turns. How many number of turns are there, beta? 200 into current. Current is 20 milliampere. 20 into 10 power minus 3. Okay. To simplify this one, we'll get the area of the cross section. See how much I'm getting? Make it fast. When torsional constant is being given, we need to use the concept of a torque beta. Torque acting on the coil is ban into your I. B is magnetic field, A is area, N is number of turns, I is your current. So when it is rotating, the torque can be written as C into theta. C is your torsional constant, theta is your deflection. So theta by I is equals to your ban into your I. This one theta is given, current is given, V is given, N is given, C is given. We need to calculate the area. So area of the coil will be equal to theta into C divided by ban into I. Only formula based type of question. Understood, student? 10 power minus 3, and this one will get cancelled. This 2 will get cancelled, isn't it? 10 power plus 3, this one, and 10 power minus 3. This will get cancelled. Okay. So now it is 0.025, 0.025 multiplied by 2 divided by 2 into 2. Okay. This one will also get cancelled. So it is 0.025 divided by 2. How much would it? 2 ones are
For
0.001.
option 4.
Yeah, 0.0125 something meter square. That will be 125 into 10 power 2 centimeters square, because options are given in centimeters. So it is 1.25.
Yes.
Only the matching answer is 1.25. Easily doable question. Only thing is you should have been got an idea. When torsional constant is being given, what is the formula to be used? Next one.
Sir, question number 3 and 4.
Huh?
Question number 3 and 4.
Question number 3 and 4. I want to do them. Question number 3, I told you, no, but question number 3, the answer is solar cell. IV characteristics of a semiconductor device is shown in figure. The device having their usual meaning will be equal to, it will be your solar cell, because Zener diode works in reverse bias. Lighting, light emitting diode and photodiodes will work in your forward bias. Solar cell will only work in your fourth quadrant. I told you while doing the semiconductors and devices also. The question number 4 is right now for me. The waves, I have not done that one. Question number 9 is the phase difference between the two SHM whose equations are y1 and y2 will be equal to how much? It's 0.05. This is your phase beta, isn't it? So this will be your phase. This will be your phase, isn't it? So what is the phase water for the first initial value? Phi1 is equals to 10 pi t plus of your pi by 3. And for second equation, pi is equals to 8 pi t plus of your pi by 4. Phase difference is how much beta? Delta phi will be equal to your pi 1 minus of your phi 2. So how much you are getting, you see? 10 pi t plus of your pi by 3. This will be minus 8 pi t plus of your pi by 3. So it is 10 minus 8. It is your 2 pi t plus this will be equal to how much for me? Pi by 3 minus pi by 4. It is pi by 12. That is the phase difference, delta phi. What time is asking? 0.2. So it is delta phi is equals to, this is 2 pi into 0.2 means right now how much for me? 1 by 2 plus of your pi by 2. So this one and this one will get cancelled. So it is a pi plus a pi by 12 delta phi. So how much you are getting? 13 pi divided by 12. That will be the answer. What it?
Yes, sir.
In which of the following optical instruments the final image is real object, the final image of real object is not inverted? Chapala. For compound microscope we get inverted, astronomical telescope also we get inverted. For simple microscope what happens? It is magnified now, it is not inverted. So obviously what will be the answer for this one? Simple microscope. Clear? The final image of real object is not inverted is asked. A simple microscope, it will be same. Because if this is the lens, if this is the object, might have been seen that object is somewhere in front of this one only, no? Image, at least distant of distant vision. Sure. Then this one. Select the correct statement regarding the electromagnetic wave traveling in your space particulation. Wavelength of the microwaves is greater than that of ultraviolet. Wavelength of infrared rays is lesser than that of ultraviolet. Wavelength of microwave is lesser than that of infrared. Gamma rays have the shortest wavelength in the electromagnetic spectrum. What will be the answer, beta? Wavelength will always be in decreasing order for this one, beta. Wavelength of your microwave is less greater than of your wavelength of your infrared rays, that is greater than of your ultraviolet, and that is greater than of your gamma rays. Okay, so wavelength in the decreasing order, if I'm writing, this is the value. Wavelength of microwave is greater than wavelength of infrared. Infrared is greater than ultraviolet, and ultraviolet is greater than of your gamma rays. So what will be the answer for this one? The wavelength of microwave is greater than that of your ultraviolet. That is true. The wavelength of infrared is lesser than that of your ultraviolet. No, it is greater. The wavelength of microwave is lesser than that of your infrared. No, that is also greater. Isn't it? Then gamma rays has the shortest wavelength in the electromagnetic spectrum, obviously. So gamma ray is lesser than all. So it should be A and D. Clear? Sure. Next one is your center of mass. Then wave optics, heat and thermodynamics, and electrostatics. So this one is atoms. Figure shows the four different situations in which the electron is moving under the uniform electric field E or uniform magnetic field B, as shown in figure. In which case the de Broglie wavelength of the electron is initially increasing. Anyone better? In the direction of the electric field, if it is this one means this will be positive, this will be positive, this will be positive, and this will be positive. Because electric field and magnetic field will start from the positive terminal. Okay? When the electron is going in this direction, so what is happening? The speed. So de Broglie's wavelength formula beta, lambda is equals to h divided by m into v. That means lambda is inversely proportional to velocity because anyhow mass will be a constant. Okay. So figure shows the four different situations in which the electron is moving under the uniform electric field or uniform magnetic field, in which case the de Broglie wavelength of the electron is initially increasing. So wavelength will increase when velocity is decreasing, in which case the velocity is decreasing better. In the first case, it is getting attracted, so it will increase. In second case, positive and negative should be attractive, but it is right now going away, so its speed is decreasing. If this speed is decreasing, its wavelength will be increasing. Okay, magnetic field not will exert any de Broglie wavelength condition. Okay, then fourth condition, this is also magnetic field, that is not possible. So only the best option I can write for this one is of your second one. Done. Sure. Next one is elasticity. 17th one. If in 5 complete rotations of the circular scale, the distance it traveled on the main scale of the screw gauge is 5 mm and there are 50 total divisions on the circular scale, the least count of the screw gauge will be equal to your how much? Anyone better? How do you calculate the least count? Least count reason he has given me pitch divided by total number of your divisions. Least count formula, so no doubt it is correct better. Pakka. Because least count is equal to pitch divided by number of divisions. The reason should be true. So first one is not possible. Second one is true is telling, but A is false. Can you see? Pitch will be equal to how much for me? Pitch is equals to, what is the distance traveled on that one? 5. Total number of divisions will be equal to 5. So that will be equal to how much for me? It is 1 millimeter for your rotation. So least count will be equal to how much better? So pitch divided by number of revolutions. That is 1 by 50. 1 by 50 is 0.02 mm. So obviously assertion is also correct. So both A and R are true beta, and R is the correct explanation of your A. Clear?
Yes.
Sure. Next one, beta. In the electrical circuit shown below, the potential difference between VA and VB will be equal to your how much? Anyone faster? Positive is connected to negative beta, isn't it? So what will be the current flowing from this one? When positive is connected to negative, V net will be equal to get add up 4 plus 4. That will be equal to your 8. So current by this one will be equal to how much? I is equals to V divided by R. So what is the current which has been flowing in this one beta? When positive and negative I am taking right now. These two are in which combination? parallel combination. So I'll represent it by your one positive cell here right now, one negative cell, and one negative cell here, and one positive cell. There is one resistance here, and there will be one resistance here. This resistance is no doubt 2 ohm. 2 and 2 are in parallel, so it is 2 by 2. It will be equal to 1 ohm. So there is no division of a current in this one. So it will be in series combination. So I is equals to V. V is equal to how much for me? 8. Resistance will be 1 plus 2. That will be equal to 3. So it is 8 by 3 is your current flowing in the given circuit. So any one you can take better. That's not an issue. Then if I'm talking about the potentials, any one potential I'm taking right now. This is A and this is your B. Start from A and come to your A back again. So VA minus of VB will be equal to current flowing in that one is right now for me I into resistance of this one is right now for me how much 1, and the next one is right now for me 2. From A to B only is asking now. So from A to B it is I into 1. I value is how much for me 8 by 3. So 8 by 3 into 1, so it is your 8 by 3 volt. Is asking only for this two terminal bit. Then Achinda,
Yes, sir.
next one. The binding energy of the nuclei P, Q and R are 110 mega electron volt, 115 mega electron volt, 234 mega electron volt respectively. Then energy released in the nuclear reaction P plus Q is giving you the value of your R. So what will be the Q value, beta? Binding energy of the nucleon, then energy released will be equal to your how much? Anyone? Binding energy of the reaction will be equal to binding energy of your reactant minus binding energy of your product minus binding energy of your Q. Okay, for all P, Q, R, he has given me the binding energies. Okay, so the given reaction is P plus Q is giving me the value of your R. Okay, so for R it is 234. For P it is 110.
Nine.
And for Q it is how much? 115. See how much I'm getting? 234 minus 110 minus 115.
9, sir.
9 mega electron volt. Very good. It will give you 9. Good question, but I practice this one. Directly formula based. Sure. Next one. Which of the following is an equivalent volume temperature cyclic process corresponding to the thermodynamics pressure PV cyclic process given in the figure, where 1 to 2 is an adiabatic process and the graphs are not to the scale part of relation. That means what do you mean by that one bit? PV graph P to 2 is in right now for me adiabatic process. So that means 1 to 2 is an adiabatic process, means in which the temperature, what is happening? Temperature is reducing, adiabatic process. Now see here 2 to 3 is right now for me, pressure is constant. Isn't it? So when pressure is constant for this one, volume should be equal to constant. Okay, then from 3 to 1, volume is constant right now for me. Isochoric process in which pressure will be equal to your constant. Okay, now you should choose a graph in such a way that it will be having these conditions, volume versus your temperature. Okay, from 1 to 2, from 1 to 2, temperature is decreasing. Obviously, see, from 1 to 2, in this one temperature is decreasing, in this one temperature is decreasing, in this one also temperature is decreasing, and in this one is also temperature decreasing. So in first one,
Obviously, sir.
3 are been increasing. Second one, from 2 to 3, pressure should be constant. 2 to 3, sorry, 2 to 3, what is constant? Volume. 2 to 3, volume is not constant here. And 2 to 3, right now in this one, volume is constant, but the second one, 2 to 3. No, 2 to 3, volume is constant.
Yes,
This
sir. Third option.
third one it is there. Then 2 to 3 are also not there. Then from 3 to 1, pressure is constant. 3 to 1, pressure is not constant. 3 to 1, pressure is not there. Now we need to write only with respect to volume and temperature. So what is the best option I can write? Third one. Done, madam?
Yes, sir.
Next one. The RMS value of the voltage of the given waveform for one time period will be equal to how much? Can anyone? For one time period means from here to here, this is your one time period. How much will be the potential value? I told you the formula. VRMS is equals to root mean square. That means we need to take the root. Then we need to take the mean of what? Current. That is nothing but I square into your dt integral divided by your dt. For one time period is asking 0 to t. So this will be equal to your under root of your, this value will be equal to, for one time period it is 1 by capital T. This is integral. Current is how much beta in the given problem? VRMS, no, so it will be V square. So it will be your 10 square into your dt. Okay. So that is equals to under root of 1 by, for one time period, it will be equal to capital T into this is 10 square is nothing but equal to your 100. Integral of dt is nothing but equal to t. This t will get cancelled. Root 100 means it will be your 10. So it will be your 10 volt. Good formula beta. VRMS is equals to your, like we write the formula like this. VRMS square is equals to integral of your there is nothing but E square into your dt divided by integral of your dt. But remove this root, it is going right now. Okay. The time period for this one is 0 to capital T, one complete cycle. E value is given in the problem as 10. So it is integral of 10 square. Integral of dt is nothing but t. This t will get cancelled. So VRMS is equals to root 100. Root 100 will be equal to 10 volt. Clear? Sure. Then 22. 22 is your fluids. 23. Figure shows the regular hexagons with the charges at the vertices. In which of the following cases the electric field at the center O is non-zero? Anyone? Wherever we need to calculate the electric field, we need to first keep the unit positive charge at that place and try to simplify it. So here you keep your 1 coulomb of your charge. Here also 1 coulomb of charge. Here 1 coulomb of charge. And here 1 coulomb of charge. Now see the direction of your electric field. Positive and negative in the first case. He is asking that the electric field at the center O is non-zero. Electric field always starts from positive and terminates at your negative. So because of this one, the electric field, and because of this electric field is in the same direction. And here right now, in this direction, it will get cancelled. And negative and one is your positive. Even in this case right now, everything is in this direction. The net is in the upward direction. Whereas in this one, all of them are positive. It will be repulsive, so it will be 0. All of them are negative, 0. Now in this one, you see, this is 2q and q. So 2q will exert the charge. So one electric field on this one is like this. This will be equal to 2e. So net will be equal to e. And here also right now for me, this will be equal to your 2e. This will be equal to e. This is 2q. Resultant of this one will be equal to e. Resultant of this one is e. This e and e will finally become for me 0. So this is also right now for me 0. Only the option is right now for me 1. Clear? The direction of the electric field is only from positive to negative beta. Because of this one, the electric field is in this direction. Okay. This is because of what charge is beta. This one is right now for me example, it is 2q. This is minus 2q. So say for example, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Okay. So electric field due to your E1 is in this direction beta. And E4 is also in the same direction. Minus and this will get cancelled right now for me. Positive. Positive and this one is positive. It will get cancelled. 2 plus 2q and minus 2q is not positive. It is not 0. So here this will be equal to E3 and it will be equal to E6. So because of this one, the electric field is in this direction. So there is one electric field. Remaining all it is becoming for me 0. You can check it out once. Done? Sure. 24th is rotation. 25th one is bar magnetism. 26th one is kinematics. 27th is modern physics. Can anyone try the question number 27 better? Faster. We don't have time. The shortest wavelength of the Paschen series is given by lambda. Then shortest wavelength for the Lyman series will be given how much? Faster, what is the formula? 1 by lambda is equals to r into 1 by 3 square Paschen series for the shortest standard gravity. It is right now for me infinity. Clear? The next one is right now for me Lyman series. 1 by lambda dash is equals to r into this will be 1 minus 1 by 2 square. So take the ratio. Longest wavelength of Lyman series will be lambda dash divided by lambda is equals to sure. So it is 1 by 9 divided by 3 by 4. So it is 4 divided by 27. So lambda dash will be equal to 4 lambda divided by 27. Third option will be the answer. Done? Sure. Question number 28. Two circuits have coefficients of mutual inductance 0.05 Henry, average EMF induced in the secondary circuit by change of the current from 0 to 20 ampere in 0.01 second in the primary circuit will be equal to your how much? Direct question. EMF E is equals to M into your change in current divided by change in time. So E is equals to your M value is how much for me? 0.05 into change in current is 20 minus 0. It will be 20 divided by how much time? 0.01. So how much it will be beta? This will be 0.01. Okay. See how much I'm getting. How much? 0.05 into 20 divided by 0.01.
Yes.
How much?
200.
100 volt. Got it? Sure. Directly formula based question. Next one, beta. Question number 29. Anyone? Two bodies of masses m and 4m are placed at a distance of r. Okay. This is one body of mass m, and this one is your 4m, are placed at a distance of your r. The gravitational potential at a point on the line joining them, where the gravitational field is right now for me 0. So somewhere when the field is right now for me 0, the net gravitational field at that point will be equal to 0. So somewhere if I'm taking that one at your x, okay, somewhere at your x it is becoming for me 0. Then other will be equal to your r minus of your x. So this is your x, this will be your r minus x. Somewhere at this point, I'm taking that electric field is becoming 0. So if I apply the gravitational field formula, gm divided by your x square will be equal to 4gm divided by r minus of your x whole square. Gm will give